Hi, this is my video number 17. In this video, I'll talk on law of limit for sequence. Law of limit for sequence. So we have a theorem which says that let's limit of an equal to a, where n goes to infinity, and limit bn equal to b for n goes to infinity. Then we have number 1, limit of n goes to infinity an plus bn, this is equal to a plus b. In fact, plus minus. Okay, plus minus means limit n goes to infinity, an plus bn, this is equal to a plus b. For an minus bn, this is equal to a minus b. And number 2, we have limits of n goes to infinity, an bn, this is equal to a b. We multiply two sequences, the same as we multiply the limit of both sequences, right? And number 3, for the quotient sequence, we have limit n goes to infinity, an over bn, this is equal to a over b, provided that b is different than 0. For the proof, I'm not going to prove all of this result. I just prove one of them, number 1. For number 2 and number 3, I leave it as an exercise to you. For the proof, so we have the limit an is equal to a for n goes to infinity. So by definition, we have given any epsilon positive, we can find any n1 say positive. Why we choose n1 here? Because we have an and bn. Okay, positive such that an minus a less than epsilon for all n greater than n1. Okay, so in this case we have two, an and bn. So in this case, I choose this is epsilon over 2. Okay, the reason why you can see in the next step that why we choose epsilon over 2. Also, we have limit bn, n goes to infinity, this is equal to b. So by definition, we have given any epsilon positive, we can find n2 positive such that bn minus b less than epsilon over 2 for all n greater than n2. Alright, now given we want to show that limit an plus bn equal to a plus b. Okay, we want to show that one. Okay, so from there, so we have for the limit an plus bn, so we have an plus bn minus the limit a plus b. Okay, you can write this as a an minus a plus bn minus b. This is less than an minus a plus bn minus b. Okay, this is from triangle inequality. Alright, now from here you have two n's. Okay, n1 and n2. Each of these epsilon. So if we can sketch this out to make it more clear. So you have a n, which converts to a. Okay, this is your a, and then you have another sequence which converts to some number b, say some number b. Okay, let's say b somewhere here. B. This is a. Okay, and this is your n1. This is your n2. We need to choose n such that it satisfies both of these. Yeah, we need to choose n, this small n, this n, to satisfy both n1 and n2. So in order to do that, we choose n bigger than any maximum between these two. Okay, so probably that is maximum. If n2 is here, n1 here, then we choose n1 as a maximum. If n2 here, n1 here, then we choose n2 as a maximum. So that if you choose n, any small n greater than n, which means those n much bigger than n1 as well as n2. So for that case, okay, we choose n is equal to maximum between n1 and n2. Okay, so therefore we have those an plus bn minus a plus b. This is less than that. This is less than an minus a. This is less than epsilon over 2 from the definition there. And bn minus b, this is also less than epsilon over 2. Okay, this is just epsilon for all n greater than n. Remember that your n in this case is maximum between n1 and n2, and this is the reason why we choose epsilon over 2. Okay, this is reason why we choose epsilon over 2, because at the end we want to show they are less than epsilon. So that's the proof for the first case. For the second case and the third case, you can I leave it to you as an exercise. Also, you can try this as an exercise. If I put limit n goes to infinity, an plus bn plus cn, you have three sequences. This is equal to a plus b plus c, yeah, where limit n goes to infinity, cn that equal to c. Okay, so you can try this. I leave that as an exercise to you, as well as these two. I leave it as an exercise to you. Okay, just a hint to you. To prove this, you will need 3 n's. Okay, n1, n2, n3. Then you can choose maximum. Choose n maximum between n1, n2, and n3. And as well as to choose epsilon, you need here we have 3 terms here. So you need to choose less than epsilon over 3 plus epsilon over 3 and epsilon over 3. Then you can just plug in using the triangle inequality. Then you can show those the limit goes less than epsilon. Okay. Now let's move on to the E. Yeah, E. I have here as a subtitle an important note on E. You know E is 2.7 71 something, right? Okay. So let's begin this from the 1 plus x to the power of n. Okay, so this is, you can expand this power n. You know this thing, 1 plus nx plus n minus 1 over 2 factorial x2 plus, I can put another one, n minus 1, n minus 2 over 3 factorial x3, okay, and plus n, you can proceed this up to x to the n, okay, you can proceed this up to x to the n. Now if we substitute x with 1 over n, so what we have, the left hand side we have 1 plus 1 over n to the n, alright. On the right side we have 1 plus, here nx, x is 1 over n, you can substitute 1 over n, so you got 1 plus, this case if you expand this, you have n squared minus n. I can factor out, I can bring out the factorial, so we have 1 over 2 factorial there. Then you have n squared, remember the x is 1 over n, so you have 1 over n squared there, so n squared cancel out, you have 1, and then this is 1 over n squared, you have 1 over n, so you have 1 over n. I hope you can see this. From that part you have n squared minus n, and x squared is 1 over n squared, so you can see this is equal to that. Okay, then you can proceed this. Next you have 1 over 3 factorial. Okay, so you have 1 over n, 1 over 2 over n. Okay, if you do this, you'll get that, and so on, plus you have 1 over n factorial, 1 minus n, 1 minus 1 over n, and so on, 1 minus n minus 1 over n. Okay, now if you look at this, if I increase the denominator of each of these by 1, so n plus 1, n plus 1, n plus 1, everywhere n plus 1, so what we have is that this will be less than, because the right hand side is bigger than, so this is less than, the right hand side is bigger than, so you have 1 plus 1 there, plus 1 over 2 factorial, okay, 1 over 2 factorial, that one you got 1 minus 1 over n plus 1, okay, plus 1 over 3 factorial, 1 minus n plus 1, 1 minus 2 over n plus 1, okay, and then you can proceed that 1 over 1 over n plus 1, so you have no problem there, so 1 minus 1 over n plus 1, okay, and so on, 1 minus n minus 1 over n plus 1, okay. So what you have now is that this is less than, you have 1 plus 1 plus that one, 1 over 2 factorial, we have 1 minus 1 n plus 1 plus 1 over 3 factorial, 1 minus 1 over n plus 1, 1 minus 2 over n plus 1, okay, and plus 1 over n factorial 1 minus 1 over n plus 1, and we can proceed those 1 minus n minus 1 over n plus 1, okay, plus 1 over n plus 1 factorial 1 minus 1 over n plus 1 until 1 minus n over n plus 1. So what you can see here, all these things are give you 1 plus 1 over n plus 1 to the power of n. Okay, so you can see here 1 minus 1 over 1 minus. So if you solve this, you'll get 1 over 1 plus 1 over n plus 1 to the power of n plus 1 to the power of n. So you can see here that this sequence is increasing. Okay, this sequence is increasing. That 1 plus 1 over n plus 1, n plus 1, this is increasing sequence. So what we want to show that this is increasing sequence, this is also increasing sequence. So if I can say that if I can show that sequence is bounded, so which means it increase, bounded, so which means the sequence converge, right? And it has a limit. So we have that 1 over 1 n over n, that less than 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus and so on, 1 over n factorial. So this equality is true. You look at the previous page that I have, yeah, you have 1 over 1 plus 1 over factorial, you multiply by something here, this is less than 1. Okay, 1 over 3 factorial, this is less than 1. Okay, this is less 1 minus 2 over, so also this is less than 1. So we have the next term should be less than 2. 1 plus 1 is 2. This is 1 over 2 factorial, 1 over 3 factorial, 1 over n factorial, and so on. Okay, so you have 1 over n factorial, and this should be less than, this is 2, all this is less than 1, so we have all that term on the right side basically less than 3. So you can see from here, that E, yeah, that E, this E is less than, so therefore we have E less than 3 greater than 2. Of course it's greater than 2 because we have 1 plus 1 plus something, so it's greater than 2, but it should be less than 3. Okay, so which means this sequence 1 over n, this sequence to the power of n, okay, it is bounded. Okay, we show here it is bounded and has a limit. Increasing sequence. From the previous page we showed that the sequence is increasing. So therefore the limit exists. So which means this sequence 1 plus 1 over n to the power of n has a limit. So what is the limit? If you look at those, we take a limit. If you take a limit, that sequence, okay, take a limit, n goes to infinity, 1 plus 1 over n to the n. So what we have, this is basically 2 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over n factorial, and so on and so on. And this is basically the definition of E. So what I can show here, what I want to show here is that the limit of n goes to infinity for this sequence 1 over n to the n, this is actually E. Okay, remember this. The limit 1 plus 1 over n to the n is equal to E. Okay. Now, if we consider okay, let x be a positive number, and we let what is symbol is that? This symbol. Okay, this symbol, which means any integer that greater than x. Okay, and let this as the greatest be the greatest integer less than x or equal to x. And for this, that symbol, normally we use this as a smallest integer greater than x. Yeah, for example, if I have 4.7. If I have 4.7, I use this definition. This is integer greater than x. Okay, so which is 5. Alright, and if I choose this, no, this is 4. Greatest integer less than 4.7 integer, which is 4. If I use this 4.7, that give you 5. Smallest integer less than greater than x should be 5. So for that, if we take x, which means x, if you look at this, if this is our x, you can see if less than 4, greater than 4, less than 5, just that one is one more than the left side. Okay, so I can write this as a, if I put that as n, the right hand side will be n plus 1. Okay, so what we have here, x is less than n, greater than n, less than n plus 1. Okay, so if we inverse this with 1 plus 1 over n, okay, that part we do the same, 1 plus 1 over x. That part is also we do the same. This will give you 1 plus 1 over n. This one 1 plus 1. Okay, because that one comes to here, this one goes to here. That one less than, that one less than. That's n. Okay, that's n. That one to power of x. That one n plus 1. So but what we have, but the limit n goes to infinity 1 plus 1 over n plus 1 to the n, this is e, and give no difference if I increase 1, just same as limit n goes to infinity 1 plus 1 over n to the n plus 1. So which means in this case, e itself, if we increase the denominator, we still got e. If we increase the power, we still get e. Okay, so in this case, we have the limit, so therefore we have the limit n goes to infinity 1 plus 1 over x to the x, this is equal to e for all positive integer x. For all positive integer x, for all x is a positive integer. So I'll give you an example. Let's say if limit n goes to infinity, I'm a bit fast I think this part, but okay, don't worry, it's not that difficult. 1 plus 1 over n to the n, that equal to e. What you need to remember that limit n goes to infinity 1 over x to the x is equal to e. That's an important thing you need to know. So we have 1 plus 1 over n to the n is equal to e. So we want to show that the limit n goes to infinity 1 plus 1 over n plus 1 to the n, this is equal to limit n goes to infinity 1 over 1 plus n, 1 over 1 over n, n plus 1, this is equal to e. We want to prove this. Okay, how to prove this? Proof. Now, if I consider m equal to n plus 1, let's say that. So what we have on the left side here, so we have limit n goes to infinity, we have 1 over, if n goes to infinity, m goes to infinity is just the same. Okay, all goes to infinity. So now for n goes to infinity, 1 over n plus 1 to the n, if I change that with m, so what we have, limit m goes to infinity, give no effect, just 1. So 1 plus, this is m, 1 over m, n is m minus 1, so we have m minus 1. Okay, so this is limit m goes to infinity 1 plus 1 over m to the power of m, power minus 1, you have over 1 over 1 over m. Okay, if you take a limit, this part by definition given here, if those equal to e, so which means this is e, so we have e, denominator we have 1 plus 1 over m, m goes to infinity, this part 0, what left is only 1, so we have e over 1 which give you e. You can do also for the right hand side, or the other one here. Okay, if you do this, what we have, the limit n goes to infinity 1 plus 1 over n, n plus 1. This is, you take a limit n goes to infinity 1 plus 1 over n to the n, and plus 1 we multiply by another terms 1 over n. You take a limit this you got E. You take a limit this, as n goes to infinity, that part is 0, what left is 1. So E multiplied by 1, you got E. So you got E. So therefore this equal to this equal to E. Alright. Okay, so I stop there for this video. Thank you.